In our recursion approach, we first import the library time, trace and alloc, and sys. These libraries will determine how the program runs, or we would use it to analyze about the performance of our program. Using trace and alloc, we would use it for tracing or tracking about the memory usage of the program. And using time, we would check it for the performance of or the time complexity or the execution time of the program. And recursion limit or sys is for the increase in recursion depth of the program. Here we have our song list. In the song list, we have the song data with our song number, song name, and song duration, and as well as our endorphin value. We have our memo dictionary. This would increase the performance for our song matrix. This would reduce the overall time consumption in our recursive function. We have the total time, which would determine the total duration of the 10 song in the song list in just one repetition. And the entire time of the song list is 3250. For the total endorphin, it is just the same for total time. It would determine the total endorphin value of the entire song list in one repetition. And the total value is 2450. We have here our song matrix function, and in this function, it would first detect if our function is at the very end of the list or if the total time limit has reached to 0, and if it does, it will return as 0. Next, we will determine if there are duplicates in our memo dictionary. And if there is, it will just return the value of that specific key or duplicate. Now, we would call in the time and endorphin of the specific song being iterated. And if the time of that song is currently greater than to the time length or the remaining time of the overall function or in the iteration, it would skip to the song and find a better time or a lesser time against the time limit. And here is our else function or else statement, which would skip the song matrix, or we would skip a song, then another would be taking a song from the using the function and the endorphin. Now we would result. We would take the maximum value of the skip and take variables, and we would put the value in the result variable into our memo with the key of the current iteration and the current time length. Then we would return our result. We have here our best 10 function. In the best 10 function, it would detect or calculate the best top 10 song from the list that would be maximizing the total time. That would mean that it would repeat another song if all song in the song list has been or at least one repeated or played. So if the song has reached to the current end of the list or there is no more time length, it would append it to the top song list with the values of endorphin, time, and top song as a tuple. Then it would stop the function. Next, we have our skip and take statements. And from the take statement, we would add it to our time, and if it is less than or equal to the time length, which is the remaining time or the current time duration, or at the very least our time duration, we would call in our function itself with the same data with time being updated with the addition of the recurrent song, and then endorphin with the recurrent song endorphin being added, then our top song with our song ID and song name as a tuple. Then we would subtract 1 so to move to the next song in our song list. And we also have a sorted top 10 function. This will be used to sort out our top 10 from the greatest function. The greatest endorphin value to the lowest endorphin value in our top 10 list. And we have our more endorphin value. This would use our sorted top 10 in list 10 because it would be using to get out our top song list or the top one and their total endorphins. This function is specifically to ask the user to use the desired time limit they want, and it would detect the total value from the total time duration they pick with the enlisting the top song. And we have our print matrix for printing out our song matrix, and we have our print top 10 for printing out our top 10 song list in a descending order. And when the program ends, it will clear out the data in our memo dictionary. Then we would also call out again time.perform counters into our end time to be subtracted to our start time or the first call of time.perform counter. Now we also get our memory usage. This would be our current mem and peak mem, which would be using trace alloc.get trace memory. Then we would stop tracking our memory using trace alloc.stop. Now we print out our execution time with end time being subtracted with start time in seconds. This would be in seconds. And then we would also get our memory usage data with using peak memory usage in kilobytes. Here is a sample run of our program, our recursive program. Here we have our song matrix, and as you can see, in 10 song we can get 2,450 in 5,000 or 5 seconds in just one repetition. And as for 1, we can get 500. For one song being played, we can get 500 in 5 seconds or 5,000 in one repetition. And here is a top 10 song for more endorphins or the maximizing the time. And our top one is have a value of 4,200 endorphins. And here we can see out our top song list, and as you can see, this one is similar to our top song number 1 because this is our top 1, and we have the total value of 4,200. Now here is where we ask the user the time limit they wish. So let's say we want it to be 8 seconds or 8,000. We can get a total value of 6,550. And this is our song list in using the number from our song list, and this is their song names. And if we want it to go 12,000, we have a total value of 9,350 of endorphins we can get. And for 15,000, we can get 11,700 of endorphins. For 18,000, we can get 14,000. And for 25,000, we can get 19,150. And lastly, if we wanted to go to 30,000 or 30 seconds, we can get a total value of endorphins of 22,950. And once we exceed it, we can get out our execution time, which been at least 2 minutes, approximately 2 minutes. Then our memory usage, 622.62 kilobytes. And that is all we have in our recursion approach.
So, in conclusion, our dynamic programming approach provides an efficient and systematic way to solve this optimization problem. So, by breaking the problem into smaller subproblems and storing intermediate results in the song matrix, we are able to avoid redundant computations and determine the optimal set of songs that maximizes endorphin levels within a given time constraint. So in addition, you also explore the recursive approach to solving the problem, while recursion follows a similar idea of breaking the problem into smaller subproblems. It tends to compute the same values multiple times, so making it less efficient compared to dynamic programming. So through this comparison, we can clearly see how dynamic programming improves the overall performance of optimizing repeated calculations, making it suitable for this type of problem. Overall, this study demonstrates how algorithmic techniques like dynamic programming can be effectively applied to real-world scenarios, such as enhancing emotional well-being through intentional music selection. So thank you for watching. God bless.